Hello, I'm Jim Dever. I'm the chairman of the Department of Chemistry and Biochemistry here at the College of Charleston, and welcome to the Major-Minor Fair. We're going to talk a little bit about chemistry and biochemistry, majoring in them, either one of those, or getting a minor in chemistry during this video. Department of Chemistry and Biochemistry is located in the School of Sciences and Mathematics building, SSMB, at 202 Calhoun Street, just across the street from the Addlestone Library. We're located on the first and third floors. You can find our faculty offices there, labs, and a few lecture rooms also. The geology department is sandwiched in between us on the second floor. We'd love to have you come over and visit and walk around and show you our facilities. I want to talk about chemistry in general, and that it's broken into 5 subdisciplines. There's analytical chemistry. I'm an analytical chemist by training. What do analytical chemists do? They analyze. They determine what substances are in a sample and how much of those substances are present, what the percentage of them are, for example. Or in very dilute solutions, what the parts per million or parts per billion might even be. Biochemistry is another subdiscipline, and biochemistry is the chemistry of life, of how enzymes and proteins and lipids and nucleic acids and carbohydrates and how all those good things happen in your body to make you a living organism and do the things that you do. Organic chemistry is the chemistry of carbon. Carbon is very special in that it can catenate, which means it can make long bonds to other carbon atoms, or a continuous chain of many carbon atoms. And so it makes literally millions of compounds. In fact, if I go back to biochemistry, those biomolecules are just fancy organic molecules. And so that's an exciting field of study. Inorganic chemistry is the chemistry of all the other elements besides carbon. And then physical chemistry is a way of studying compounds and atoms, their chemical and physical properties. It also has a lot of math that's associated with it. These are my colleagues in the Department of Chemistry and Biochemistry, and they're wonderful. They're great folks. And many, if not all of them, could have been at big research universities doing big-time research. But they want to be here in an undergraduate institution where they can teach and come to know you well in your classes, and also to do research. And they do cutting-edge research, and you're invited to be a part of that. We'll talk a little bit more about that in just a little bit. But they're associated with those 5 different disciplines that we just talked about. Chemists have a lot of neat toys in our disposal, and there's a 400 megahertz NMR that we have, nuclear magnetic resonance. That's where you put a sample in a tube. It could be a liquid or it could be a solid for that matter, and put it in a high magnetic field and bounce radio waves off of it. You can determine the structure of the molecule from that. We have a fast protein liquid chromatograph that you can take mixtures from biological samples and separate them out into different compounds very quickly. A liquid chromatography mass spectrometer is shown on the upper right there, and that's the type of instrument that the professional sports teams and the Olympics use to bust athletes, to tell you the truth. Where you can biological samples, somebody's urine, and do a drug analysis very quickly on it. Atomic force microscopy is a technique that's used in physical chemistry to study atoms and molecules on surfaces. And electron paramagnetic resonance is another spectroscopic technique that we can use to study molecules. Chemistry is a lot of fun. Here I want to show you an experiment that I like to do at the start of each semester, is to dissolve a penny in nitric acid. And you can see it bubbling and fuming and dissolving and giving off these noxious brown fumes. And that's just one of the types of experiments that we can do in chemistry. And so mixing things together, that's an awful lot of fun, besides playing with those neat instruments that we just saw. So there are two different degrees in chemistry that you can get, a BA or BS. BS, you've taken a few more courses, you're a little bit better prepared for whatever might come next. But they both will prepare you for graduate school, medical school, dental school. Within the BA track, we also have a possibility of going to teaching, where you take a lot of courses in the School of Education. We need great high school teachers, so if you want to think about doing that, that'd be super. We usually have 1 or 2 students every other year that go that route. So those are the chemistry degrees that we offer. We also offer a biochemistry degree. And that is often used by students going into medicine, going to med school, dental school, and whoever have a great liking toward the biological world. But it has an awful lot of chemistry within it, of course. So what can you do being a chemist or a biochemist? There are all sorts of job opportunities in industry, in government, in business, going into sales, pharmaceutical sales, in the regulatory industries to help companies make sure that they're EPA compliant, and forensics, all that CSI sleuthing that you see on TV, that they have chemists do that. And it's also a great path, as I've sort of mentioned along the way, to go to medical school or to dental school or law school. You could become an environmental lawyer, for example, or go to pharmacy school. Chemistry is a fairly packed 4-year curriculum, and so you want to get started in it soon if at all possible. And so this is a layout of the 4 years, and we're not going to spend time to do that. If you want to come over and talk about that, we certainly do that. There's some math that's involved in becoming a chemistry major. That physical chemistry course that I mentioned is very calculus-based, and so you need either 2 or 3 semesters of calculus. There are 2 different paths that you can go to do that. You also need a year of physics, once again, for that physical chemistry course. And then if you're taking the biochemistry route, you'll want to take a few biology courses along the way. But we can talk about those in more detail or with your advisor once you declare a chemistry major. We have some really neat electives that you can take as you progress past those first couple years of introductory courses. We teach courses in environmental chemistry, chemical biology. There's an advanced organic course that we like to offer. We actually have a field course that we offer. You can study abroad in Costa Rica. They go down there during Maymester. We have a chemistry of alcohol course. You've got to be 21 or older to take that. And we have bioanalytical chemistry that combines the biochemistry with the analytical chemistry and do some really neat experiments with that. And if you're not so keen on doing lab work, we have computational chemistry that you can, courses that you can participate in. Mention that undergraduate research is very important, and you can do academic year research or summer research with the SURF program, and we have funding from the School of Science and Mathematics and also from the National Institutes of Health through the South Carolina Embry program. And you can wind up publishing your research in a journal, which is really great for your resume and applications for graduate and medical school, and present papers at conferences, and we'll pay for your way to travel to state, regional, and maybe even national conferences. But there are a lot of exciting projects that you can do. In analytical chemistry, for example, you can study nanoparticles or the degradation of pharmaceuticals in the environment. In biochemistry, we can do some cloning and study enzymes and do some really neat things there. In terms of organic chemistry, you can design these large molecules and learn how to make them from much smaller molecules. In inorganic chemistry, you can also learn how to make some new molecules that way. In physical chemistry, we've got some lasers that you can come play with as you study nanoparticles and microwave spectrometers to study molecules with, and that's also a great computational realm to go into. So that's just some of the things that you can do with a chemistry or biochemistry major. You can also minor in chemistry. And if you're a biology major or a marine biology major, oftentimes by just picking up a couple extra courses, you can get a chemistry minor. And so what is involved with a minor is past the 111, 112 sequence or the honor sequence, if you've done that, is a year of either organic chemistry or physical chemistry. Most students do the organic chemistry route, one course in analytical chemistry, Chem 220, Introduction to Analytical Chemistry, and that gives you a lot of the lab experience and really makes you employable even as a chemical technician after you graduate. And then you need one other course beyond that, and oftentimes students will do the biochemistry course, which is Chem 351, because so many folks are pre-med that are in the biology world. So that's a little bit about major and minor in chemistry. Thanks for visiting with me. I am Dr. Jim Dever once again. You can call me Dr. D. I'm located in Department Office 324 of the School of Science and Math building. There's my email address and my phone number, and I'd love to talk to you if you'd like to major or minor in chemistry. Thanks so much for joining me, and take care and good luck.